Hi there, my name is Jacopo Panerati. I am a postdoctoral fellow at the University of Toronto. I am super happy to be recording this video for the 2020 RSS Pioneers Workshop. My research focuses on deep multi-agent reinforcement learning applied to planning and control of UAVs. I think we can now say that deep learning has, if not solved, at least efficiently mitigated many of the historical limitations of reinforcement learning. Yet, deep reinforcement learning still has a number of practical problems. They include numerical instability, brittleness, reproducibility, and in the context of robotics in particular, scarcity of real-world datasets. The multi-agent scenario, on top of that, is, at least in my opinion, an extra layer of complexity that makes the problem more interesting, but also more challenging. So in the last few years, I've tried to work on both the engineering and the theoretical aspects of robotic multi-agent reinforcement learning. Our contribution in these years, Amos, for example, used augmented reality to bridge the so-called reality or sim-to-real gap in a multi-vehicle setup. On this note, I actually want to add that I think it's also important we focus on offline reinforcement learning to bridge the sim-to-real gap, and that's part of my current research. On the more theoretical side of my research, I think the hardest question still is how to systematically design decentralized policies and control laws leading to desired behaviors, what are called emerging behaviors in swarm robotics. There has been some success in using value function mixing, for example, but a complementary approach, I think, is borrowing from game theory. The idea of setting up the problem as an adversarial game in between learning agents. And this was at the core of the work I did on adversarial private flocking with Hui Zhang, and it's something I'm continuing to work on. So with a target behavior in mind, one only needs to specify the end goals of the players, and the learning agents pursue them against progressively stronger opponents or environments. So this is not necessarily the most computationally efficient way of doing so, but one thing I like about this sort of adversarial approaches is that they can have useful side effects, like the derivation of strategies that had not been foreseen by a human designer, or the creation of policies that are more robust to disturbances or imperfect sensing. So I look forward to chat and share these ideas with you on July 11 and talk to you soon.